Hello, this is a quick start on the SMAC actuator. The one I have right here is the LDL 25C. We have the LDL 25 and the LDL 25C. The difference is they have the built-in controller on the LDL 25C as it shows there. That has the three major components, which is the linear guide, the encoder for position feedback, and this one has a 5 micron resolution, and then it has the moving coil, which is a printed coil and magnet assembly inside. And so this one has the controller built into it. It's on the back side. For connection, it has a high density 26 pin connector. I have a cable that is another option that you can add to this. It's on page 2 of the drawing, which is downloadable from our website. On the opposite end, it has 3 cables coming out of it. One of them is the 9-pin D-sub connector for connection to your USB to 9-pin adapter cable for programming, downloading, or for retrieving data out of it. You don't have to have it connected after the program is downloaded to the controller in its non-volatile memory, but if you want to continue to receive data back out or information, that's available. And then the second cable is the I/O connector. You'll notice that this particular one is a high density 26 pin connector also, but I've got another mating connector to it which has jumpers on it for the STO. This actuator has safe torque off as an option, and if you're not using it with any external safety devices, then you'll need to put these jumpers on it for it to energize the motor. The third cable is for the power supply, your plus and minus for V plus and V minus. This is going to a 48 volt power supply, which is powered on, plugged in. As far as downloading to the controller, we can go to the SMAC website, which is smac-mca.com. And then if you go up to the top left, there's products, down to controllers, and then select any of the VLCs, and you'll see an option or a tab at the bottom for VLC editor. When you click on that, download it, and you're ready to go. The next thing is the VLC editor. As you can tell right here, since the power supply is turned on, it'll immediately show connected, and then you can see COM port 3. It's set for a baud rate of 9600, and there's 2 windows that are here. One is where you put your program. The other one on the right side is for the actual terminal of the controller. So if I left click on it and hit the escape key a couple times, you'll see the greater than sign that's showing me I do have a connection with it. If you don't get the greater than sign, then it means that you're not connected, and it's probably something with the serial communication cable that's not connected. Either that or this will say not connected as well. As far as the program is here's a sample program we can send to you. This has the PIDs, the homing routine, the phase detect because it's a three-phase motor. There's a routine here for slow, medium, fast move, jogging, and then a soft land routine. Does like 5 of those, and then just loops back to the beginning and repeats. You'll notice that it has a PS on the bottom, and that's for programs saved, so it saves it to non-volatile. So what I'm going to do is copy the complete program here. Oops. Right click, copy, and then go over to the program editor. Left click on the left side, right click, paste. And then to download it, you just go to the greater than sign right here, and that will download your program to the controller. Okay, and it did PS, so it saved it. Now going back to the I/O connection, I just want to make a point on that. Well, as you can see from the drawing, this has the outline of the cable as I have laid out. But then I also have here noted what the safe torque off jumpers need to be. So if you're using this cable, this is what your jumpers need to be in red. The blue and the green are for I/O connections, but I just wanted to make a note on the STO jumpers that are mandatory if you don't have an external device attached to it. So here's a blown up view of it. Once again, so on this connector, you're connecting 10, 11, and 19 to 5 volts, ground and STO common for the other side. If you want to go directly to the actuator without using this cable, but your own, you can do that. So you just need to have, these are the connections on the actuator itself that need to be made. For those in red are the STO. Okay, so as far as running the program, it's very simple. On this particular actuator, this has a 50 millimeter stroke. As you can tell, it's a non-rotating rod. Female shaft tip is what's in there. And then if I just hit the run a command right up here, it'll run macro 0, which is the beginning of the program. And the actuator will start to do a phase detect. It'll say phasing successful, and then linear home. And now it's starting on a canned routine. So now it's jogging back and forth, and then it'll go into the soft land routine. So if I stop it at any point in here, it'll recognize that surface and abort and come back. And it's just doing a repeat canned loop. And that's it. So to stop this, if I wanted to interrupt the program, I just hit the escape key, and you'll notice on the right side here, let me click in that window, it will interrupt it. And then if I want to turn the motor off, I just type MF, and that turns the motor off. And that's how you get this started.